We're a live feed from Argentina. Today's great total eclipse, Latin America. Here we go. Okay, broadcasting live from San Jose. San Jose de Jacal in Argentina. We see the sun halfway through the partial phase of the eclipse, where the moon, exactly 400 times closer to us, but yet 400 times smaller than the sun, is a perfect geometric cover for the sun. And hence we have this unique phenomena, perhaps in all the universe, where we can see the beautiful ethereal aspects to our star, the sun, such as the solar corona, the solar chromosphere, and of course the prominences that we're all used to seeing associated with the total eclipse of the sun. We have two observers here stationed also at San Jose de Jacal in Argentina, Graham Jones and Ann Buckle. They're there witnessing the eclipse happening in real time on the ground, and we see a live feed via telescope of the eclipse. Now it should be understood also that observing the partial phase of the eclipse, that's the full disk of the sun. There's no difference between any exposed area of the sun during eclipse and the sun during daylight hours, regular sun. They need a filter for this. So we're seeing the sun colors modified as it passes through a cover, which is on the front end of the telescope, severely mitigating the sun's full brilliance. We can see along the limb of the sun what we call limb darkening, which is an aspect of the sun where we're looking into a deeper, we're looking through more of the sun's atmosphere, hence the amount of light we see will be attenuated and we'll see less of the sun. It'll appear slightly dimmer. That phenomenon is called limb darkening. Okay? The shadow of the moon as it races across the surface of the Earth is basically traveling at the orbital speed of the moon. It's about 1,400 kilometers an hour, and it's very fast. So the total phase of the eclipse will last a little more than 2 minutes, about 2 minutes 38 seconds at full eclipse. And this map over here, you can see this point here is where we're going to see the full eclipse of the sun. Listening to Graham Jones and Ann Buckle on the ground, live in Argentina, at San Jose de Jacal in Argentina. Yep, so it's 25 minutes to totality, full eclipse. This live cast from Argentina is courtesy of timeanddate.com. They have a telescope on the ground, on location, in San Jose de Jacal in Argentina. Again, this is Dr. Jim Daly with Astronomy for Change, hosting this live broadcast on YouTube. You can also see when you look at the disk of the sun, the photosphere. This so-called disk of the sun is not a solid object. The sun is a giant sphere of superheated plasma under enormous temperature and pressure. At the core, we have a thermonuclear fusion reaction ongoing, produces the sun's light and heat. And as that heat propagates up through the sun's interior to the surface, we have convection cycles of convection. Those ascending and descending columns of superheated gas that are now cooled and descend, those cycles are what causes this granular appearance on the sun's surface. Also noticeable is the sun is devoid of any other features like sunspots. Sunspots are indicative of internal activity or crossovers in the sun's magnetic field, basically causing a breach of the energy transmission to the surface, hence causing that particular area on the sun's surface to appear darker. Less energy appears darker to us, but still enormously hot. The surface, the photosphere temperature of the sun is 5,800 degrees Kelvin. Kelvin is the universal scale used in science. Centigrade and Fahrenheit require offsets to better understand them, but the Kelvin scale is based on absolute zero, where zero is actually absolute zero, or the presence of no energy. So the sun's surface is 5,800 degrees Kelvin. Associated with that temperature is a specific, what they call color temperature. You might have heard this terminology used often, sometimes in lighting in your home. They talk about Kelvin or color temperature. The higher that number, the bluer the color. Okay, so daylight, the term daylight suggests a 5,800 degree Kelvin color temperature. So that's the color temperature of the sun. Over here, we have a smaller black and white image of the same. You won't be able to see the prominences, the jets of hydrogen gas leaping from the sun's surface until the full phase or the total phase of the eclipse begins, because relative to the brightness of the photosphere, all these other features and aspects of our star are much, much dimmer by comparison. Hence, they just, you can't see them because they're simply so much fainter. The outer tenuous atmosphere of the sun, called the solar corona, is measured in millions of degrees Kelvin. Okay, but it's very thin and very tenuous. And in fact, our Earth, in its orbit around the sun, does orbit in the outer extremities of the solar corona. But we don't get any effect from that because it's so thin and tenuous at this distance. Distance to the sun is 150 million kilometers. We call that one astronomical unit. And in some astronomical literature, you might see distances described in terms of astronomical units. Basically, it's one Earth-Sun distance as a unit we call an astronomical unit. For example, the distance to Jupiter is 5.2 astronomical units, things like that. The distance to Pluto is 40 astronomical units. And here we are. This is the mid-eclipse occurs at this point right here. We're approaching that in a little bit less than 20 minutes. The time indicated down here is universal time, which is basically the local mean time in Greenwich, England. That's the universal standard, coordinated universal time. For observers on the east coast of North America and for the location here in South America, this would be exactly equivalent to Eastern Standard Time, which is 4 hours. So 20 hours minus 4 is 16 hours, 20 minutes, which is 4:20, which is exactly the time in Eastern Time right now. It's 4:20. This live feed is brought to you courtesy of timeanddate.com, where all your time and date information needs can be met in any time zone, any location in the world, in the Earth. Don't forget, please do leave us your questions and comments in the comment section below when we finally, post this video to our YouTube page. Be delighted to hear from our subscribers and answer your questions. Okay, Jim Daly here, still here, waiting on the, you notice that the sun is getting increasingly thinner and narrower as we approach totality. The total eclipse only happens, could only possibly happen once every month during the new moon phase. As we know, the moon goes through a 29 day cycle as it orbits the Earth. When the moon is perfectly in front of this, between the sun and the Earth, you have the total eclipse. That's 2 weeks before and after the new moon phase. Okay, this is the only time of the month where we could have a total eclipse. Getting there. Those of you who are just joining us, welcome. Again, I'm Dr. Jim Daly, Astronomy for Change. I'm one of the resident astronomers that contribute to the organization, whose mission is to promote astronomy, science, and education, general education that will benefit all of society. And we invite you to join at our website, astronomyforchange.org. You can become a member. It's free. There's no requirement. We have a section where we write articles of wide interest in astronomy, events such as this. We're involved in public outreach and helping schools with education in science and astronomy, specifically science generally. And our mission is to basically elevate society, raise awareness of the great universe beyond, and make it available to everybody. Positive change in the world using astronomy, specifically, and science generally, as a medium. That's our general mission. Again, we're watching the partial phase of the eclipse, quickly approaching at the rate of 1,400 kilometers an hour, which is the moon's orbital speed. That's the speed the moon's shadow is racing across the surface of the Earth, still out over the Southern Pacific right now. Over here you can see it. Here. This center point, that's what we call the umbra. That's the central shadow of the moon's, the central core of the moon's shadow, and only in that section will you be able to see the total phase of the eclipse. Everything else in the extremities here, we call this the penumbra, and out here we don't see an eclipse at all. Anything beyond this shadow here, we will not see an eclipse. Okay, it's about to make landfall very soon, in less than 10 minutes, 9 minutes to go. This is probably one of the most awe-inspiring events in all of nature, is to watch the disk of the sun disappear. The ancients, not having understood what it means, considered it an omen from the gods, that the gods were displeased with them, and they would often sacrifice, do things to appease the gods and have the sun return. Within a few minutes, it comes back. The sun returns after displaying its beauty. This is Graham Jones and Ann Buckle on the ground in San Jose de Chacal in Argentina. Yeah, they're talking about a temperature drop. I witnessed the total eclipse of the sun on July 11th, 1991 in Cabo San Lucas in Mexico. And there was a significant temperature drop. The sky was perfectly clear. The sun was totally overhead. It's not even 10 minutes. It's at 2:38, 14:38, 4:38. 8 minutes to go. They're experiencing technical difficulties. Well, that's perfect timing. As long as we don't lose the image of the sun, we should be all right. I suspect this is a communications issue with our witnesses on the ground in Argentina. But we still have the live eclipse feed, which is really all that matters at this point. So we get to witness this spectacle 8,000 kilometers away. Oh, another important detail that should be mentioned is the width of the shadow on the ground is no more than 100 kilometers wide. So if you're outside that 100-kilometer shadow of the moon, you don't see the total eclipse, even though it looks like it. Well, maybe we'll make it. No, they're back again. Okay, so that's the umbra. The penumbra is exterior to that, and beyond the penumbra, we don't see the eclipse at all. So, see, they're using their glasses. No, we lost their feet again. See if you look at the map right here, you see the umbra is just touching the coast of Chile at this point, but we're in Argentina, so we're a little bit away. Okay, so in La Serena, in Chile, on the west coast of Chile, they're experiencing totality at this moment.
We're back?
Yes, we can hear you.
We're back?
The anticipation is mounting. In 5 minutes, we will be witness to totality at 2038.
2, 1. And 3, 2, 1. Well, we had some issues there.
Yes.
Unfortunately, before totality.
Yeah.
Okay.
Fortuitous, isn't it?
So we're now about 7 minutes away
Yes.
from totality. The key features to look out for about 15 seconds before totality. The solar corona, a sort of a ghostly shimmer.
He's going to be speaking about the diamond ring effect.
Also, the present sun gets thinner and thinner until about 15 seconds before totality. There's one final brilliant jewel of sun.
We call that the diamond ring.
And this jewel of sunlight, together with the solar corona surrounding the sun, this gives us the effect of a diamond.
It's called the diamond ring effect, where the last rays of the photosphere glint through the mountains and valleys of the moon as the sunlight passes over the moon's surface, coming towards us. That's called the diamond ring effect.
Daly's beads. And this is the very, very final beads of sunlight that we can see coming to us through the valleys on the edge of the
Mountains and valleys of the moon.
very final beads of sunlight until all of the sun disappears and then totality has begun.
And then we see it all again after 2 and a bit minutes.
And then here in San Jose de Hachal, we have 1 minute 56 seconds of totality.
There
Now,
we go.
Anna,
See?
you and I have some work to do
Yep.
during totality
Yep.
because the solar corona is much dimmer than
Yeah, we
the
discussed
sun
this.
itself.
So we could never see this during daylight.
Changing filters on our telescope in order to bring the solar corona images.
No, they should not be using any filters at all on their telescopes. In fact, right now they're using a filter,
During totality.
and that will be removed when totality begins, on the onset of totality.
So the solar corona, it's about as bright as a full moon.
Yeah.
And of course, it's perfectly safe to look at the full moon without eye protection. So the solar corona is safe to look at without.
This is absolutely true.
That's only after the diamond ring. That's only after the last of Daly's beads has winked out until totality.
Okay, so here we go. We're looking at this map again. By the way, for those of you who are wondering what this is the nighttime. So the continent of Africa is at night. During the night, here we are. The umber, the moon's umber, is now just making egress into Argentina. It's on Chile already. 2 minutes to go to totality. 2038. Here we go. Look at this. This is a general wide field view of the sun with the mountains in the distance. Beautiful scene in Argentina. San Jose de Chacal in Argentina. You can see they have a very nice time bar here, timeline, right here. This is totality, this little space right here, and this is where we are right now, at 2037 hours, universal time. This is back to our telescopic view, with a smaller black and white duplicate on the side there. A few short minutes, 2 or 3 minutes to go for totality. Even in myself, I can sense the anticipation is palpable, because there's nothing like seeing this. I witnessed one on July 11th, 1991, at the southern tip of Baja California, Cabo San Lucas, in Mexico. It was phenomenal. The sun was directly overhead. If you go to our website, go to the stories and articles section, the news and articles section, our latest blog post, I present a picture there that I took, my eclipse adventure in Mexico 27 years ago. 28 years ago. Another 2 minutes to go. The moon shadow is racing along the surface of the Earth at this point at 1,400 kilometers an hour, roughly. We're approaching the point during the eclipse when we're going to have the diamond ring. With the moon, the sunlight, the last vestiges of sunlight will be filtering through the mountains and valleys of the moon as it comes towards us as observers on the Earth. We're blessed down in Argentina to have crystal clear skies, beautiful clear skies in the latter part of the afternoon. Very soon we're going to start to see the diamond ring. They're changing the image scale here, which means they're probably getting ready to take off the filter. They should be removing the filter very soon. Totality is just a few seconds away. Filters should be coming off now. And we have totality beginning right now. There it is. You see the solar corona. That's the hot outer atmosphere of the sun. All of this halo around the sun is this solar corona. We don't see any prominences as yet. This will last for approximately 2 minutes, 30 seconds. Maybe they could break to the wide field view. That would be nice. You can see the coronal streamers. You see this feature here, where the corona seems to be streaming away in these ribbons or streams. That's caused by the sun's magnetic field, very powerful magnetic field, called coronal streamers. That's what these are here, along the edge. Up here at the pole of the sun, the north pole of the sun, here we see them quite prominently. You can see the solar corona is a kind of a bright turquoise, blue, green, yellow mix. If they reduce the image scale on this, it would be very good. There we go. You can see here, it appears to be shimmering because the sun is lower in the sky, and it's, even though, there we go, there's the wide field view. Flock of birds flying. This is what happens. The birds are fooled into believing that night is coming, and here we go with the totality ending. It was a very brief eclipse. The birds believe that it's the onset of night, so they start flying towards their nesting grounds. We observe this all the time with eclipses. Okay, that was the end of totality. This is what's now called third contact, which you see right now, is the emerging crescent sun. We call this third contact. The onset, very beginning of the eclipse, is first contact. Totality, second contact. Third contact is now, when totality ends. And fourth contact is when when the limb of the moon just completely passes away from the limb of the sun. The sun being 400 times bigger, yet 400 times further away than the moon. Hence we have a perfect geometric fit, perfect geometric cover. Brilliant eclipse. Brilliantly clear skies, thanks to our friends in Latin America. This is the great total solar eclipse of Latin America for 2019, 2 July 2019. I'm Dr. Jim Daly with Astronomy for Change, hosting this event. You can still see the birds flying by the sun in the wide field view. Basically, what we're going to see now is reverse of what we saw leading up to this point. The moon will continue to move, the moon's shadow will continue to move across the surface of the Earth. Pretty soon the sun will be left alone in the sky, as it was before it began, the eclipse. Again, we're in San Jose de Chacao in Argentina. We saw the mountains to the west of us in the brief wide field view. We saw mountains that would be the Andes Mountains along the west coast of Chile and Argentina. We were looking west. Right now we're looking west towards the setting sun. And again, as I mentioned earlier, please leave your comments, suggestions, and any questions you have in the comments section of this video, which will be posted as soon as possible. We here at Astronomy for Change are excited to hear what you have to say, and we'll try to answer your questions, and any suggestions we'll take seriously. And please do consider becoming a member. You go to our homepage, astronomyforchange.org, click the red membership button. It's free to join. You get frequent newsletters and email updates on the latest happenings in the world of astronomy and the universe above us. Okay, I hope everybody enjoyed this. Video, this live view of, this is our first live event here at Astronomy for Change. Hope everybody enjoyed this, and it's the first of many. We're going to try to do these more frequently. There's another event that I just learned about earlier today. Was another outburst occurred in the enigmatic star Eta Carina. It's been a supernova or a nova that's been occurring for the last 200 years. And we observed today with the Hubble Space Telescope another outburst. So we're going to take a look at that and produce another video. And we'll see what happens with that. Anyway, okay, this is Dr. Jim Daly with Astronomy for Change signing off. I hope everybody enjoyed this video. And please do leave us your comments and suggestions below. Thank you.